Chapter 4 is titled Electron Configuration, and there are multiple sections to this chapter. First, some background information just to refresh your memory to help you get into the gist of this chapter. Remember that the electron is one of three subatomic particles, the others being the proton and the neutron. The electron is located in the electron cloud, which orbits around the nucleus. It's a very large region, and the electron has a negative charge. So the first concept we have to talk about are quantum numbers. So there are four quantum numbers that are used to describe the actual location of each electron in an atom. And remember that E with a negative sign is the abbreviation for electron. So these are the four quantum numbers, and you'll learn about each. So you have the principal quantum number, the angular momentum quantum number, the magnetic quantum number, and the spin quantum number. So first, the principal quantum number. This number describes the energy level that an electron is in based on its distance from the nucleus. So they are levels, level 1, level 2, level 3. They're rings, although the electrons, it's not like a hula hoop, but they do orbit, kind of like the planets do, in a circular pattern. And each level is numbered based on its distance from the nucleus. So the higher the number, the farther from the nucleus. So you can have levels 1, 2, 3, 4, 5, 6, and 7. So the higher the energy level, as I said, the greater the distance. And the greater the distance, the greater the energy of the electron. And this is because the electrons have more room, they're able to move more freely because they have more space. So principal quantum number is the energy of an electron based on its distance. Keyword is distance from the nucleus. The farther away, the higher the level, the greater the energy. The second quantum number is the angular momentum quantum number. This describes the shape of each sublevel. The sublevels are S, P, D, and F. So within each actual level, 1, 2, 3, 4, 5, 6, or 7, you can also have one or multiple sublevels. So the S sublevel is spherical. These are all three-dimensional shapes. It's like a ball. The P sublevel, I like to say it's like a dumbbell or an infinity sign. The D sublevel is like a four-leaf clover. And then the F sublevel, we just say, is a complex shape. So angular momentum quantum number describes the shape of S, P, D, and F with their specific shape listed. The third quantum number is the magnetic quantum number. This describes the orientation or the placement of each orbital around the nucleus. And we're going to take the word orientation, the number of orientations, to also mean the number of orbitals. So the magnetic quantum number tells you the orientation or the position of the orbitals and also the number of the orbitals. This is a little bit hard to fathom on a two-dimensional plane like a picture I'm showing you. So just worry about the numbers. Don't look too far into the actual physical placement. So sublevel S has one possible orientation. Remember, S is a sphere. It doesn't matter which direction you turn that circle, it's going to look exactly the same. So therefore, it only has one orientation and one orbital. So S has one. P is like a dumbbell. So there's three possible orientations. So you can have this orientation, which is horizontal on the x-axis. You can have this orientation, which is vertical on the y-axis. And I know these are numbered or labeled differently. Just pretend this is y. And then you can also have this jutting out towards you diagonally from the screen. That would be Z. So horizontal, vertically are actually coming out of the screen. P has 3. S has 1. P has 3. D, which we said is a four-leaf clover, has 5 possible orientations. So you have it horizontally across the X, vertically on the Y, coming out at you to the left, coming out at you to the right, and then a complex shape. So D has 5 orientations and 5 possible orbitals. So S has 1, P has 3, D has 5. And lastly, F, we said, is a very complex shape, and therefore its orientations are also complex. Just know that F has 7 possible orientations around the nucleus, and therefore 7 orbitals. So the best way I can tell you to memorize this is S has 1, P has 3, D has 5, F has 7. The magnetic quantum number tells you the number of orbitals and orientations around the nucleus. S1, P3, D5, F7. SPDF 1357. If you can remember that, you're good to go. So, before we move on to the last quantum number, we have to think about what the magnetic quantum number means for actual electron holding. So a single orbital can hold 2 electrons. Now we have to fill in this chart. So level 1 has 1 sublevel S. S has 1 orbital, so this is the principal quantum number, the angular momentum quantum number, and the magnetic quantum number. So level 1 has 1 sublevel S, and S has 1 orientation or orbital option. For every orbital, you can have 2 electrons. So in S, the 1 orbital, there's a max of 2 electrons. So for this entire level, since S is the only orbital or sublevel, you can have 2. So level 1 can hold a maximum of 2 electrons. S can hold a maximum of 2 electrons. Level 2. Level 2 has sublevels S and P. Once again, S can hold 1. Once again, S has 1 orbital. P has 3. You can put 2 electrons in every orbital. So S can once again hold 2. And P can hold 6 because 2 plus 2 plus 2, 2 in every orbital is 6 total. So S can hold 2. P can hold up to 6. Add these together, we get that level 2 can hold up to 8 electrons. Level 3 has S, P, and D sublevels. We know S has 1 orbital holding 2 electrons. We know that P has 3 orbitals holding 6 electrons. And now D, we said, has 5 orbitals. It can hold up to 10 electrons, 2 in each orbital. So S can hold a max of 2, P can hold a max of 6, and D can hold a max of 10 electrons. Add these together, we get that the total number of electrons in level 3 is 18. Level 4 has S, P, D, and F sublevels. We already talked about S, P, and D. We said that F has 7 orbital or orientations. 2 electrons in every orbital means that F can hold a maximum of 14 electrons. So adding these all together, we get that level 4 can hold a maximum of 32 total electrons. And level 5, 6, and 7, there's only S, P, D, and F sublevels, so it's just repetitive of level 4. A lot of information, but here is the big picture. We said that S can hold 2 electrons because it has 1 orbital, 2 in that orbital. P can hold a max of 6 electrons because it has 3 orbitals, 2 in each orbital. D can hold a maximum of 10 electrons because it has 5 orbitals, 2 in each. And F can hold a maximum of 14 electrons because it has 7 orbitals, 2 electrons in each. I tell students to remember, once again, let me go to a new page. We said that the sublevels are S, P, D, and F. S has 1 orbital. P has 3, D has 5, F has 7. 2 electrons in each of these means that S can hold a maximum of 2 electrons, P can hold a maximum of 6 electrons, D can hold a maximum of 10 electrons, and F can hold a maximum of 14 electrons. Here is what you need to memorize. SPDF 1, 3, 5, 7, 2, 6, 10, 14. Memorize that like a little jingle, and you know that there is the sublevels, you know the orbital orientations for the magnetic quantum number, and you know the total number of electrons within that sublevel. SPDF 1, 3, 5, 7, 2, 6, 10, 14. Memorize that. The last quantum number is the spin quantum number. This one actually makes sense given its name. The spin quantum number basically tells you which direction an electron is spinning. And there's 2 options. It can either spin clockwise or counterclockwise. And when there are 2 electrons in an orbital, that's the maximum that an orbital can hold, they will spin the opposite direction to not interfere with each other.